Dear distinguished guests and valuable Formnext teams, hello and welcome. Sorry for my excitement. This is my first speech in the international community. Here I'm going to share our story of our journey about how we come to this point. Vertical axis wind turbines out of 3D printers. My name is Serkan Ozkan. I'm from Constructor University, Research Associate, and I'm here on behalf of Professor Yilmaz Uygun. My ex-work, I used to be a yacht designer, and we built many modern spacecraft-like things in the past. Our curiosity and passion never stopped us, and we wanted to try new things, even vehicles, electric vehicles, and different type of manufacturing methods. And as you see from different type of production methodology, I will not go into because of the time. I will quickly make the slides and talk about it. There is the yacht that we produced in the past out of our design, and different technologies in electric drivetrain systems, drones, and wind turbines. Finally, we come to the point. That's how we come to this point. You see that on the left side are new generation vertical axis wind turbine, and the right side, the printer that we developed specifically to print wind turbine. Basically, industry is not really believe still the additive manufacturing is ready for end product and the serial production. However, we think about not the serial production, is the parallel production using the things. How we start our journey is kind of a postmodern design, vertical axis wind turbine on top of sailing like a boat. However, it's not a sailing exactly. They're using the turbine as a motor that can drive or store energy inside. So basically, before we start, it was like a hobby project that the best yacht is your friend's yacht normally, but we always wish to have ours as a friend, a team. And we analyze different type of wind turbines, and we find the vertical axis are much more suitable to use with it. And however, despite the inefficiency mark in the literature of vertical axis, we find research about it, and we see the advantages. I will not tell more, that just go quickly. We combine two types of technology that's called drag and lift technology. So therefore, we find something new, and with the collector that we can collect wind from larger area, and the focus just like a lens does for light. And therefore, we have a unique and a beautiful design, and so many diverse ideas comes out of it. And finally, we made a floating type wind turbine, which can be house or anything, or restaurant. It is huge. It's 20-meter diameter, or 30-40 meter high, and can be built in the land and dragged to the offshore. It's much more cheaper. But the key is printed by 3D. So therefore, we don't use experience like we use in the yacht industry. That is what we do in the first glass fiber and molding. But anyway, we use 3D printer to make our molds and our gadgets or alternator trials, anything made out of this. So our first trials was taken place in our house and on the shore, and it was one of the video out of it. It is 2-meter size. It's around a 500-watt peak, and it is many trials. We use 3D printer. That it's really helpful to evaluate. It's easier than injection molding or whatever. So I will come to that point. So we made also simulations out of it, but additive manufacturing was much more effective for us and our little trials. And we compare which kind of production method is the best before. There was plastic forming looks promising, but On the other hand, the composite is, which is our experience. We want to get rid of it because this is not. It looks like environment friendly. The wind turbine is made with non-environment friendly product that is not recyclable, and it's also pollution. Therefore, we analyze plastics. In the other world, they say it is not climate friendly, but the plastic actually can be recyclable unlimitedly. So yeah, there is some limit for sure, but many times as the others. Therefore, it is for us as like a marketing. It is more environment friendly, but using the molds expensive, and if you need to evolve your design, in the end we keep evolving it, making it more efficient. We decide to make a wind turbine out of 3D printer, and so we analyze the type of printers and the kinematics. We find the Delta is much more faster and a rapid production tool, and we started to make our almost 3-4 meter high, and later it's changed and the final shape takes this. And we start in the university, in the Bremen Constructor University, and our friends, students always passing by. And on the end, our happiness that first calibration, again, the community comes with their help. Somebody comes before Instagram photo, but still we consider as a support, no problems. So that's our final shape and our celebration. So we come to first slicing as on the left side of the top segment of our turbine that we slice and we print, and after we assemble them like something else I couldn't say now. Of course, not always success. Sometimes we failed, but we learn out of our failure. So our first collector-based turbine is printed and successfully seen. There is even not much wind, which literature says is inefficient, but we made the most efficient vertical axis turbine. It's also beautiful, not noisy and things. Good thing is sustainability comes with additive manufacturing. Unlike today's people say plastic should go out of our life, I believe we should keep them more, because why they say plastic is bad? Because it is not able to degrade in the soil, but we believe something degrade in the soil does not belong to that, it's a pollution. So that's another bad thing for environment. So therefore, plastic can be recycled many times in our control. Therefore, it's more environment friendly, and we made it most environment friendly printer. You see that for 3.5 meter high turbines made like segments, but still an ongoing project. It's taking time. We're handling problems. So therefore, we keep developing our tools. So we find the most feasible production with rotary printer. So there are some rotary printers here, but they are mostly made with rotating arm and robotic things. We find it unnecessarily complex and made for marketing, I believe. It could be very simple, just like a lathe machine. It's also easy to scale up. You can rise up the head, extend the rails. We don't care about centimeters, because these meters, 24 meters, 50 meters, could be still feasible in the industry. Even for the space, we're considering that, such as complicated wind turbine part. Imagine you need a tool in the Mars or the Moon. Today, maybe next year, we will go to Moon for mining. You cannot carry a huge container. You need to carry, such as machines with raw material, extend the machine and print your container. And such as technology is actually used in carbon fiber filament winding technologies. 800 bar pressure is sufficient enough. So it is proven technology. So we go on top of it to make it printer. So therefore, you can put in the container and ship it to a site and print your turbine wings there and get rid of a lot of operation costs. Even that you can put many printing heads, could make it parallel. Your build platform, basically the shaft, is much more reliable. That's why we consider spaces are one of our targets after renewable energy, because our build platform is rolling on top of the shaft. That is not requiring gravity. So that looks like amateur filament FDM printer, but it could be also metal printing using metal filament, or powder fused by the laser or electron beam. But we want to start with FDM and pellet extrusion. That's how we want to recycle things and make it useful. And this is our next target, to make it giant metal printer with 12 laser powder. So many thanks to Constructor University that giving us opportunity to research in the valuable way, and our founder Kieserling Foundation and Exist, and special thanks to Formnext that giving us opportunity to express our feelings. So basically, our design is awarded at 2014 in Korea, but we unfortunately never had a chance to realize it. So nothing feels than realizing a dream. So better. Sorry, I couldn't express that. Thank you very much.